Hello, everybody. Now that we're all hyper concerned about the coronavirus, I thought I'd present some interesting information. This is just stuff that I've discovered on my own. I'm just playing around with the data. First, I went to, thanks to one of my students who introduced me to this idea of using this coronavirus map that's produced by Johns Hopkins University. And if you can just Google coronavirus map Johns Hopkins and press the link here. It says coronavirus COVID-19 global cases map. And it's really cool because it's up to date and using multiple sources, pulling from multiple sources like WHO, CDC, etc., to get the latest number of deaths or cases and total recovered. But what I'm really interested in is the prevalence, how many cases there are. So in this case, prevalence and incidence number of the new cases are pretty much the same because everybody's a new case. So I'm very curious about why Italy has so many cases in comparison to, say, France, Spain, Germany. So what is it about Italy? So people would say, well, the virus spreads and it's just going from place to place. Well, I don't see it that way because there's a lot of traffic between, say, the United States and China. I'm not so sure how much it is in comparison to Italy, but I'm sure there's plenty of travel. Yet our cases to date are 761 to Italy at 9,172. So these things intrigue me, and I look at countries that are surrounding Italy, like Austria. We don't have that many cases, and I pulled them out on this spreadsheet here. And also look at India because India is a massive country. These are the populations as of today. What is today? Today's the 10th of March, 2020. So you can see China and India have quite large populations. Yet China only has 56 cases, known cases, versus 80,757 in China. Well, one could say, well, people don't travel between there. Well, I don't necessarily agree with that. People always travel from country to country. So here's the United States, and this is the deaths in the United States. You can calculate deaths for these groups as well. I just haven't done it yet. And here's the UK, which is a relatively large country, 321 cases. Germany. So I'm looking at countries that border Italy. I'm also looking at other countries like Spain, France. So you can see that the number of cases in no way match Italy. Switzerland borders Italy. Slovenia borders Italy. You're seeing just a great disparity there. So what I'm going to do is I'm going to compare China to Italy. So when we're looking at the number of cases, this follows what's known as a binomial distribution. It's a count of the number of successes that you have. In this case, successes, and we're not using this in a qualitative fashion. Success means a number of whatever it is that I'm looking at. I'm looking at the number of cases in China versus the number of cases in Italy. And because this is such a large, these are large populations, I can use what's known as a normal approximation of a binomial. And if I use a normal approximation of a binomial, I have all the wonderful characteristics of a standard normal distribution available, which is, for those of you who know stats, you think of it as a z-value, something about the standard normal. It's that bell curve that you think of. And there's, using that bell curve, we know that there's with this rule called the 68, 95, 99.7 rule, where we know that 68% of all population values lie within plus or minus 1 standard deviation of the mean, 95% between plus or minus 2 standard deviations of the mean, and then 99.7% of all values between plus or minus 3 standard deviations of the mean. But anyway, we can do all that, and we can use this to calculate a z-value. A z-value will compare the mean, in this case, between the two groups. So it's the mean difference between the two groups, right? So I'm comparing that to a population difference of 0. In research, we do what is called null hypothesis testing. I know there's people who are against this type of testing, but let's just use this for now. So we're comparing the difference that we observe between Italy and China to the difference that we would expect to our null distribution difference, which is 0. There's no difference versus there is a difference. But before I get to that, let me point out a couple of numbers here. This is the prevalence per 100,000 individuals. So in China, the prevalence, and again, I know the virus was located in one area, but before people knew of the virus, people were free to travel everywhere. So let's not pretend that we always knew that people were sick or were in the incubation stage of the natural history of COVID-19. So we didn't know that. It's 5.61 individuals sick per every 100,000 Chinese. And in Italy, it's 15.17 per every 100,000. That's a pretty big difference there. All right, let's take a look at the total populations in each country. We're going to use this to calculate the difference in proportions and in different groups. Let's see what we got here. This is the total number of the total population for Italy and China together, and the total number of cases when we add Italy to China. And this is the proportion of individuals who are confirmed cases, right? Q is the complement of having the case. So this is the probability of not having the case. By the way, so that's 1 minus the probability of being a confirmed case, right? COVID-19. If you look at the probability of not having it, it's 0.999994. So if you think about that, what's the probability of me not having COVID-19 if I was a member of either of those two countries, a citizen of either of those two countries? That's pretty high, right? Now, this is the difference in the proportions between Italy and China. So this is all used to calculate the z. I need the standard error. So I have to calculate that. I calculated the standard error. So I just did all these steps to go here, and a z value that I ended up getting is 94.03769, which is really, really high. As I mentioned, these are standard deviations, right? So you think about it, 94.03769 standard deviations from the mean. That has a giant, a very, very small p-value. So the probability of this observed result, given the null hypothesis is true, is very, very small. So yes, they're significantly different. We can tell that by looking at that. I also created a 95% confidence interval surrounding this mean value, and these are all the things I needed to calculate it. M stands for my margin of error. I had to do a lot of steps in there. So let's look at the confidence intervals, and not multiplying by 100,000. It's really difficult to capture what these mean, because it's like 5 spaces to the left, right? 1, 2, 3, 4, 5. Moving the decimal point to the left, it's a small number, but if I multiply it by 100,000, as I did here, so this is the difference we have between Italy and China. It's 9.559143 cases per 100,000, and the difference can be anywhere as small as 9.246 to 9.872. So, right, so, and since this confidence limit doesn't cross 0, we know that there's a significant difference between the two. So just in a nutshell, this is just I'm just playing around here, trying to understand this. And I'm also trying to alleviate fears that people have that I know, because it's the probability of one being infected with the coronavirus is very, very small. Anywhere in the world, probability of one dying from it is very, very small too. So if you think about it, I would, unless you're, of course, in a group that's very fragile or has some kind of a health condition. But this difference between Italy and China was very intriguing to me. Like, what is it about Italy? What are they doing that so many people are getting infected over there? Is it something that's the way people behave, or what? I'm just very curious about that. Anyway, that's all I have. All right, bye.